All right, let's just jump right into one of the most famous and maybe one of the most misunderstood thought experiments in all of science. We're talking about Schrödinger's cat, of course, and a simple question that feels like it could unravel the whole thing.
I mean, it's a great question, isn't it? It seems so ridiculously obvious. If the cat's life or death is tied to some random quantum event, but you've got a heart monitor hooked up, constantly checking its pulse, well then you already know if it's alive or dead, right? You don't need to open the box. That whole idea of it being alive and dead just seems to completely fall apart. And the short, kind of surprising answer to that question is, yeah. Yes. Sticking a heart monitor on the cat absolutely ends the whole experiment before it even gets started. But here's the real kicker. That common sense objection you just had, that's not a flaw you found in the experiment. That is the experiment. It's the whole sarcastic, brilliant point that Erwin Schrödinger was trying to make. He cooked up this insane scenario to poke holes in an interpretation of quantum mechanics he thought was completely absurd. Your gotcha question? That's the punchline he wanted you to get all along. So to really get why that is, we have to fix a word that pop culture gets wrong pretty much all the time. And that word is observation. See, this is where almost all the confusion comes from. We think of observation as a person, consciously looking at something. But in the world of quantum physics, it's way, way broader than that. An observation is any physical interaction at all. It's any process that gets the quantum system tangled up with the big, messy world around it and lets information leak out. It has absolutely nothing to do with consciousness. Okay, so let's just trace the path of our heart monitor. First, the sensor has to physically touch the cat, right? That touch, that physical interaction, creates an electrical signal. That signal then zips down a wire. At every single one of those steps, information about the cat's state, alive or dead, is escaping into the macroscopic world. And poof, the superposition is gone. It's destroyed the very second that monitor is turned on. The observation has already happened, long before any person peeks into the box. So the most important thing to get here is that a quantum observation isn't some person's mind magically choosing a reality. Nope, it's just a super fragile quantum state getting forced to pick a side, all because it got bumped into by the big, clumsy outside world. And that heart monitor? That's a really, really big bump. And this wasn't just some neat little puzzle for a textbook. This was a central battleground in a huge debate between the absolute giants of 20th century physics. Let's break down where they all stood. Schrödinger, the guy who invented the cat, was basically using it as a weapon of satire. He was saying, look, if your theory leads to a zombie cat that's both alive and dead, then your theory has a serious problem. Then you have Niels Bohr, one of the main architects of the theory. He'd just pragmatically say, the moment you have a device that can measure the cat, it's not a quantum system anymore. The question is pointless. And then, of course, there was Einstein. For him, the cat was just more proof that quantum mechanics was just plain wrong, or at least incomplete. This famous quote from Einstein just perfectly captures his whole deal. He deeply believed in an objective reality, something that exists whether we're measuring it or not. The very idea that something as real as a cat or the moon could be in some fuzzy, undefined state until we looked at it was to him just total nonsense. The cat was his exhibit A for why the whole theory was just lacking. So how do we square this all today? Well, physicists now have a much better word for what's going on, and that word is decoherence. Decoherence is basically the modern-day explanation for this whole measurement problem. What it says is that all that quantum weirdness, like being in two states at once, can only really exist in perfect, total isolation. The second, the very instant a quantum system interacts with its environment, even with just one tiny air molecule, its quantum properties just rapidly leak away, and it's forced into a single, normal, classical state. And this explains perfectly why we never, ever see a cat in a superposition. I mean, a cat is a huge, warm, complicated living thing. It's bumping into trillions of air molecules every single nanosecond. It's giving off heat. It's breathing. It is decohering itself almost instantly. Long before you could even think about closing the box, that cat is already either 100% alive or 100% dead. Okay, so let's tie all of this together and really lock in the actual takeaway from this whole famous thought experiment. So the main thing to remember is this. Schrödinger never, ever believed in a half-alive cat. He was using it to point out a problem. That heart monitor idea isn't just a valid objection, it's the entire point he was trying to make. The big misunderstanding always comes down to that word observation. It's all about physical interaction, not a person's consciousness. And finally, our modern understanding of decoherence gives us the physics to explain exactly why a big object like a cat can't ever hold on to a fragile quantum state in the real world.
In the end, the real lesson of Schrödinger's cat isn't really about quantum mechanics. It's a warning. It's a warning about taking a scientific theory and stretching it to a place where it just doesn't belong, creating something that's totally absurd. And that kind of makes you wonder, what widely accepted ideas we have today might look just as strange if we really push them to their logical extremes.